of 4.3. So reference angles are any angle in standing position whose terminal side lies on one of the four quadrants, and A is the acute angle of the positive measure formed by that terminal side. So what that looks like visually is if we have first an acute angle like so, where all of these are off of the positive x-axis, this angle would be the same as the reference angle. So nothing special there, and that's in quadrant 1. For quadrant 2, we would have our angle like this. So this is our theta. So our reference angle would be here. It's just what's the acute angle between the terminal side and the x-axis. For quadrant 3, there. So our reference angle is there. In quadrant 4, our reference angle would be here. So when we're using these formulas, you want this between 0 and 360 degrees. So if you're outside of that, either negative degrees or bigger than 360, use your coterminal angles to get them to be strictly between 0 and 360. Then we've got reference right triangles, very similar of what we were just drawing. I won't draw them all out. I'll do the quadrant 2. So there's our angle, right? And then this is our reference angle here to here. So the reference triangle is there. So you just basically make a right triangle where that reference angle is then included. So we want to find the reference angle for each of these. 210 degrees, it's helpful to draw a picture of these. So 210 degrees, 90, 180. So it's somewhere in here. This is 180 degrees. So the reference angle, A, would just be 210 minus 180, which is 30 degrees. 135 degrees, that's less than 180, so we're somewhere in here. 135 degrees, this is 180 degrees. Our reference angle, remember it's the acute angle that's made between the terminal side and the x-axis. So that would be 180 minus 135, should be 45 degrees. And for 422, first thing you need to do is get that between 0 and 360. So that would be 62 degrees, not 60 degrees. So then 62 degrees is before 90, so it's somewhere in here, which is the same as your reference angle. So that would be 62 degrees. And then when we're finding trig values, which we're going to be doing next, we use what quadrant they're in, because the quadrant will tell us whether the x or y is positive or negative. So we use the idea of quadrants to then help us find the values of trig functions using these reference angles. So if we have 60 degrees, 120 degrees, 240 degrees, and 300 degrees. The reference angles for each of these is 60 degrees. 60, 60, 60, 60. Then the reference triangles are all going to have the same values. Where the hypotenuse is 2, because these are 30, 60, 90 triangles. Let's do a different color. Let's do, so that's 2, 2, all the hypotenuses are 2. The short legs are 1. And then the y values are square root 3. So then if we're looking at the points, this would have an x value of 1, a y value square root 3. Here we'd have negative 1 square root 3, because on the x-axis it's negative to the left. Down here, this point would be at negative 1, negative square root 3. And then this one here would be at 1, negative square root 3. So as we're solving now for these angles on the Cartesian plane, you got to think about what quadrant is the point in, or the angle in, and then that will tell you whether x and y is positive or negative to then get the correct trigonometric value. Here are your steps to evaluating trig functions. Go ahead and pause the video and write this down. All right, so finding the exact value of 210 degrees. So first, I always find it helpful to graph it. So that's 90, 180, 210, somewhere in here, which means our reference angle is 30 degrees. So we're using a 30, 60, 90 triangle here. So it's a quick refresher. 30, 60, 1, 2, square root 3. So 1 is opposite the 30. Square root 3 is next to the 30 or adjacent to the 30. And this is 2. So now we got to figure out for our point here, it is negative 1 or negative square root 3, negative 1. So then the cosine of 210, that's adjacent over hypotenuse, so it's square root 3 over 2, but then we gotta look at the sign for cosine. That's the x value here. X is going to the left, so it's going to be negative square root 3 over 2. Negative 7 pi over 6. So we want our angles to be positive. So the first thing we're going to do is take that negative 7 pi over 6 and add 2 pi to it to put it into a positive value. So that would be 5 pi over 6. And then remember, this is pi 0 or 2 pi, which means this is pi over 2. 5 pi over 6 is bigger than pi over 2, but less than pi. So we are here. And so then to get our reference angle here, oops, let's do a different color. Here, we're going to do the 180 degrees. Here it's pi minus 5 pi over 6, which gets us pi over 6. So then we're going to do cosecant of pi over 6, which is the same as 1 over sine pi over 6, which is equal to 1 over 1/2 equal to 2. And then you check the sign for sine. So sine's going to be the y value here. So it's this value here over the hypotenuse here. So because of that, it's going to be positive. So our answer is positive 2. For a quick reference for y'all to have, sine and cosine are both positive in quadrant 1. Sine is positive in quadrant 2. Cosine is negative in quadrant 2. Quadrant 3, they're both negative. Then quadrant 4, sine is negative, cosine is positive. For a question like this, well, first off, we need to know what we're looking for. So it's when sine of theta equals negative square root 3 over 2. First thing we want to figure out is what quadrants is sine negative in, which would be quadrant 3 and quadrant 4. Then we want to find our reference angle. So our reference angles are always looking at basic quadrant 1, so we want to find where it's positive. So sine of 60 is equal to square root 3 over 2. So we look at the positive value of this to find our reference angle, and now we use that reference angle to find the values in the quadrant. So our reference angle is 60 degrees, and we know we're in 3 and 4, so we're over here and over here. So we'll be looking at where this angle is 60 degrees and where this angle is 60 degrees. It's coming off of 180, so we would do 180 minus 60 and 180 plus 60, so we get 120 degrees and 240 degrees for our answer. And we check to make sure it's within our restriction, which it is. So for something like this, where there's lots of words happening, basically all we're going to do is we're going to look at sine of theta equals negative 0.6293. Notice how there's no degree symbol here, so we're using radians here, so make sure your calculator is in. Actually, never mind. Cancel that. So then we do inverse sine of both sides to solve for theta. So theta is going to be equal to roughly 39 degrees. So that's our reference angle. Now we know that we want to find the terminal side in quadrant 3. So looking at our graph, quadrant 3 is down here. So that means our reference angle is here, 180. So we're going to do 180 plus 39, and we get 219 degrees. Now, if you did sine of 219 on your calculator, you should get the value that we started with.